Hello, this is Ms. DB, and in this video I'm going to review how to do the segment addition postulate problems 10 through 15 on the Chapter 1, Section 2 worksheet. So first of all, there's this example, which is similar to the problems that you're going to be doing. It says that S is between R and T, find RT. RT is the length of the whole segment from R all the way to T. And we are given some expressions. We're given that RS is 2x plus 7 long, ST is 28 long, and RT is 4x long. So you're going to start each of these problems 10 through 15 by writing an equation. And the equation that you're going to write is that the whole line segment, in this case RT, will be equal to the sum of its parts. So in this case, RS plus ST. So RS from here to here plus ST from here to here is equal to the whole thing. Well, that makes sense. Then we just replace these lengths with their expressions. So we know that RT is given as being 4x. We know that RS is being given as 2x plus 7. We know that ST is given as 28. So then it won't let me draw. Well, it's not letting me draw, but that's okay. It doesn't seem to recognize my pen, but that's okay. We can see that then the next step would be to combine your like terms. 2x is the only x term. 7 plus 28 is 35. So we get 4x equals 2x plus 35. So this is all algebra. All of this in here is algebra skills that you learned when you took Algebra 1. So we have a 4x on the left, and a 2x on the right, and we have to subtract so that we get our x's together. Subtract 2x from both sides, and we get 2x equals 35, and then we divide both sides by 2, and we find x. Now we're not done. The question didn't say find x, it said find RT. So now we take x and we figure out what's RT. RT is 4x. So now I can take 4 times what I got for x, 17.5, and that's how you get the answer of 70. All right, now you're going to do the same thing. So all I'm going to help you do in this video is set up the original equation using the segment addition postulate. So the segment addition postulate says that the whole segment, in this case JL, will be equal to the sum of its parts, the two pieces together, JK plus KL. And then we take and we replace JL with its expression. Well, JL is given as 7. JK is given as Y. And KL is given as 5. So that's we're not done. We will take that and solve for Y. And then go back and say, what are we looking for? We're looking for JK. Well, that is equal to Y in that example. So in that example, once we figure out Y, that's going to be equal to JK. Okay, let's set up the equation for number 11. In number 11, we're going to take the whole segment, which is AC, and that will be equal to, let me tab that over one more time so it doesn't keep moving on me, will be equal to AB, part of it, plus the other part, BC. And then we need to replace AC with what it is given. Its length is given as 14. And AB's length is given as 8. And BC's length is given as Z. So we'll find out what Z equals by solving that. And then we'll find length BC, which in this case, just like the last one, that's going to be equal to Z because BC is Z. All right, let's go on and see if number 12 is a little more work. In number 12, it's a little bit more work. We have to find SV. So same original equation. We're going to say that the whole line SV is equal to its parts, so ST plus TV. And then we have to replace SV with the expression. It is 2n. This one's going to be a little bit more algebra because there's a variable here. Oh, my minus sign didn't come out. 2n minus 1 that will be equal to, let's see, ST is 20 plus, hey, where did it go? Sorry, 20, there it is, plus N. Now in this one, when you solve your equation, we will have to subtract 1N from both sides. This N is the same as 1N. And we'll have to get our N's together. All right, and so we're not done. We'll have to find N, and then we'll have to plug the value of N back into 2N minus 1 to find the answer. In 13, WY, that's the whole length, will be equal to the length of its parts added together. And so we're going to use that in all of these problems in this section, where you will be replacing now those lengths with what the expression is. So we have 36 would be equal to A plus 6. And then we have 1A plus 1A will be 2A, so we'll have 36 equals 2A plus 6, and then you'll have to finish it from there. Once you find out what A is, you still have to plug it back in, because we need the length of XY, which is A, whatever we get for A, plus 6. So we won't be done once we find A. We'll have to go a little farther. Okay, and then 14 and 15 are the fun ones, because there's a little bit more algebra practice to do here. So in number 14, we need to take that the length of the whole segment, KM, will be equal to its two parts added together. And then we will replace KM with 3x plus 1.5, and we will replace KL with x plus 0.5, and we will replace LM with 3x minus 2. Now on this one, we're going to have, like I said, more algebra to practice. You still have to combine your like terms on the right side. So we have 1x plus 3x. And let's see, we have plus 0.5 minus 2 ends up being minus 1.5. And then you still have, we're not done yet, but that gets you started on that one. And then going back to number 15. Let's see, in this one, the whole length of the segment is SU, and its parts are ST and TU. And then you have to replace SU with 2y minus 4, and you have to replace ST with y, and you have to replace TU with 18. So that's your equation to find y. And in both 14 and 15, once you find x or once you find y, you still have to replace that back into the expression for the part that you have to find. I think in 15, y is equal to st, so 15 will be quicker. All right, I hope that helps. Let me know if you have other questions. Come to my office hours or to the ASC when I am there. Thank you. Have a great day.